Hello and welcome back to the second part of the restoration of the tape mechanism. So we cleaned everything the last time. Unfortunately, it was not working. It eats the tape. I have already cleaned the pinch rollers and that's one of the reasons, of course. I forgot to make any pictures, but I can see from the very first picture there was a little bit of glaze on the top of the pinch rollers. I haven't found compatible pinch rollers with the same diameters and size. I think it's nearly impossible to get them. So what I did was to clean the pinch rollers with some sandpaper. I used some water for this. I have done this already here, I just demonstrate how I did it. Then click on play and hold the sandpaper to the pinch roller and only for some minutes. Then try. Other side too, just hold there, and that was working quite fine. They're looking like new. And that solved the problem with the tape, that the tape got eaten. So that's working. But unfortunately there were also other problems, or one other problem. Basically it did this. Sometimes it happens very often, and sometimes only after some minutes or seconds. Now that's an interesting issue. And my first idea was to measure the signal at the real motor. It might just to understand, is it a problem of the mechanism, of the mechanics, maybe the wheel I replaced, or is it an electrical issue? And as we can see, there is a significant drop in the voltage. So that's an electronic problem and has nothing to do with the mechanism itself. Next step is to check what is the input into the motor driver. And we can see there's a disruption in the signal. Interesting. The signal from the microprocessor is always high, so this cannot be a problem. It must have something to do with this correction circuit here. According to the service manual, it sends a correction impulse for the real motor when it stops. And it seems that there is a small signal coming from this circuit, but this can only happen if the capacitor 2549 would be not working. So I measured the signal at the capacitor and this was the result. And we can see clearly now there's a disruption in the signal. And lucky me, when I turned the PCB for the measurement, the capacitor fell apart. So it was just broken, and from time to time it gave a wrong signal. And I had one capacitor, an SMD 1206 at home, so that was perfect. And it's now replaced, and now check again if it's working or not. Next thing I'm going to do is to measure wow and flutter, and it would be absolutely awesome if I would have such an wow and flutter meter, but unfortunately I don't have such a meter. And I also do not have a test tape with 3.15 kilohertz recorded on it. You can buy those very expensive test tapes on eBay, for instance, for $55 in this case. But those people are also recording their test tapes on a simply tape deck, on their own tape deck, so I'm not sure if they are working perfectly or not, if they're really accurate. I don't want to spend $55, really. I don't. That's too much. But what I do have are 3 different tape decks from Denon, and I'm used them for calibration. And this is for sure not very professional, and someone will hate me for this, but I'm going to do it anyway. And this might be a method you can use if you have other tape decks and if you want to check if you're more or less at 3.15 kilohertz. So the tape decks I do have is a Denon DRW 850 and a DRM 700A. They were quite good tape decks in the 90s, and for sure they're also not calibrated, and they're maybe also not 3.15 kilohertz, but I'm going to record a tape on each of the tape decks and will calibrate the CD555 tape deck to the tape deck which is in the middle of the measurement for the three tape decks. For the measurement I'm using a software which is freely available. Unfortunately I cannot create a screencast of it because on my MacBook for thousands of euros it's not possible to get a line in, so I had to use my very old Windows laptop with Windows XP, as you can see. However, this is working perfectly, and I'm going to add the link to this software in the comments to the video. And as a result, I get 3 different frequencies from the recorded tapes, and I'm going to calibrate the CD555 tape deck, in this case to the tape deck A, so that the tape from the tape deck A has 3.15 kilohertz on CD555. To change the speed on a capstan, there's a small potentiometer on the rear side. Trust me, it will drive you crazy. Only a little bit of movement will have a dramatically change in the speed, so this will take some time. And we can see the result here on the screenshot. It's 0.1149% deviation in the speed. I think that's quite good for this tape. It's not a professional tape like the Denons. And we also need to consider that we are also measuring the volume flutter from the Denon tape deck. So I think we can go with that. Last thing to do is to repair the soft eject function. It's sometimes not working, as you can see. It was quite hard for me to find the material used for the soft eject, which is basically a plastic wheel, and in between there's a liquid or grease, something like that. I was asking several people and also repair shops here, radio repair shops in Austria, and no one had any idea what this is. So what I basically did, I ordered some silicone oil in different viscosity. We have one with 35,000 CPS, one with 50,000 CPS, and one with 100,000 CPS. That was basically just to try which is the best. And I can tell you it's the 100,000 CPS. I'm going to replace it not only because, as you've seen, sometimes it's not working properly. That's quite too fast. And maybe it's possible to see here, it's getting liquid and it's down here, and sometimes you can see this also on the bottom of the inside of the sound machine. So what we need is some pads. I'm using a little bit of alcohol to clean the area here where I need to apply the grease or the oil, silicone oil. I just use nail polish remover for this task, and now we are going to apply the silicone oil. You can use a brush. I'm just using the pads that I have here. Not sure if this is Japanese or Chinese. Well, that's much better now. It's working all the time. Great. If you watch carefully the mechanism, you can see the capstan flywheels are missing. Well, this is the tip mechanism from unit number 4, and look what happened to the capstan wheels. Oh, the gear is broken, lost almost all the teeth. That's going to be a challenge to repair. We will see how we can get on with that. But I'm going to do this also with the unit number 3. And here we are. Working fine. Perfect. Okay, and when I reconnected everything, I noticed that it was not possible to record anything. Well, it's important to connect the undocumented cable from the microprocessor panel to the cassette panel, because it delivers some power supply for the record function. Having a look how the Aries head is working, we can see there's a switch on top. With this switch it's possible to switch between different record modes if you're recording from a radio station with high frequency or something like that. And usually the position is in the default position, is 0 position. It's not needed. But this brought me an idea to start there at this point for the measurement, and I found the problem really fast. And if you have a look at the resistor 3871, you can spot that it looks a little bit weird, and it seems to be a common issue in this machine that some of the SMD parts are getting broken for whatever reason. And when I removed the resistor, it just broke, and replacing the resistor solved the problem, and record is working again. Well, considering how the tape deck looked like and it was not working at all, I think that's quite good. We can do some tests, and also for recording when we assemble the machine. But for now, we are finished with the tape mechanism. And as always, thanks for watching and see you next time. Cheers!